Hi friends, welcome to Curie Electronics. Today we are going to solve VSSC 2017 question paper for Technician B Electronics, that is Electronic Mechanical. We will start with the first question. Question number 1. If 1 microampere current is flowing through a conductor, then the number of electrons flowing through in 1 second are 1 microampere of current flowing through a conductor, then the number of electrons flowing through in 1 second are. Now, what is Q? Q equal to I into T. I into T. We have one more equation. What is Q? Q equal to number of electrons multiplied by the charge of electron. So we have these two equations. Using these two, we can calculate it. That is Ne equal to I into T. What we need the number of electrons. Current is given, so N we need N equal to I T divided by E, which equals, what is I given? I given is 1 microampere, 1 into 10 to the power minus 6. T equal to 1 second. What is the charge of electron? 1 into 1.6. 1.6 multiplied by 10 to the power minus 19. Now what we get? 1 divided by 1.6 is 19. When it goes up, what happens? It will be 10 to the power minus 6 multiplied by 10 to the power 19 plus 19. So we will get 1 divided by 1.6 multiplied by 10 to the power 13 we will get. Now what is 1 divided by 1.6? I'll write it this side. 1 divided by 1.6 equal to what? 1 divided by 1.6, which equal to 0.625 multiplied by 10 to the power 13. This is 13, okay? 10 to the plus 13, correct? Plus 13, because plus 13 comes plus 13. I thought you are okay. Plus 13. 10 to the power 13. So which can be written as 6.25 multiplied by 10 to the power 12. So many number of electrons required to make 1 microampere of current. So the answer is option D, 10 to the power 12. Question number 2. Second question. Electrolyte used in nickel cadmium rechargeable cell is. What is the electrolyte? Is nickel cadmium cell, that is potassium hydroxide, that is KOH, potassium hydroxide. Now what is the voltage of nickel cadmium cell? It gives a voltage of, what is the voltage? It gives 1.2 volt. 1.2 volt. Next question. What is the value of inductance of a coil? We have to find the inductance of a coil of 100 turns wound on an iron core of relative permeability of 200 if the area of the cross section is 1 centimeter square and length is 4 centimeter. This question, this is based on air core inductor. So For an air core inductance is equal to mu naught mu r a n square, that is area of the inductor into number of turns divided by the length of the inductor. That means if you have an inductor like this, we have to find the area, then length. We should know length and area to use this equation. Now in the question he has given, what is mu naught? Mu naught is given as 4 pi into 10 to the power minus 7 multiplied by, what is mu r? He has given us 200. What is area? Area is given in, see this is in meters. Area is given in centimeter. We have to convert into meter. That is 1 multiplied by 10 to the power minus 4. That is in meters. The length, okay. A n square. Oh, I not write the n square. I have to write n square. What is the number of turns? 100. So that is 100 square. 100 square divided by, what is the length? 4 centimeter. 4 centimeter we have to convert to meter. What is the relation between 10 centimeter and meter? 100 centimeters makes 1 meter. So you have to multiply it by 10 to the power minus 2. 10 to the power minus 2. Now we will solve it. Okay. This can be written as 10 to the power 4. See, this and this cancels. And this also we can cancel it and write it as 10 to the power minus 5. 4 and 4 cancels. Now we left with the pi multiplied by 10 to the power minus 5 multiplied by 200. 100, now 200 is there. 628 we get. That is 3.14 into 100. That is 314 multiplied by 2 into 10 to the power minus 5 we got. So this can be written as 6.28 into 10 to the power minus 3. That is 6.28 millihenry. So 6.28 millihenry is the answer. This is the equation you should know. This is for the air core inductor. Millihenry. So we'll go to the next question. The maximum safe working voltage for a series combination of two capacitors of rating 2 microfarad 10 volt and 4 microfarad 20 volt is. Okay, when we are connecting two capacitors in series. When two capacitors are connected in series, this is the V. V we have to find out. Then two capacitors are connected in series. What are the values? 2 microfarad and 4 microfarad. The charge is going to be same total charge, the Q is going to be same through, but the voltage V1, this will be voltage V1 and this is going to be voltage V2. V1 and V2 is going to be different. Now we'll find the equivalent capacitance. First we'll find the equivalent capacitance. C equivalent equal to what? 2 multiplied by 4 divided by 2 plus 4. Similar to resistors in parallel. So 8 by 6, that is 4 by 3, which comes to 1.3. 1.3 microfarad. So 1.53 microfarad is the total charge, total capacitance. Okay. Now we will take the, what is the charge, we will find out. What is charge? Total charge, QT is given by C equivalent multiplied by V. Now first, see this one capacitor is 10 volt, another capacitor is 20 volt. So first we will take the middle value, that is 15. We will take it as 15. What happens? 10. I will take first 10. Okay. So if I take 10, what happens? C equivalent value equal to what? C equivalent value equal to 1.3 microfarad. That is 1.3 into 10 to the minus 6. I am taking 10 volt. So I will get 13 into 10 to the power minus 6 coulomb I will get. Now I want the voltage drop. What is the voltage drop? Now I will find out V1. V1 equal to what? Q equal to CV. Okay, Q equal to CV. From here, V equal to Q by C. Okay. Now, what is Q? Q we already got. For the 10 volt, I have found the Q already. That is 1.3 into 10 to the power minus 13. 13. Sorry, 13. This is 13. Okay. Sorry, it's not coming. Okay, it's 13. V1. V1 equals to 13 into 10 to the power minus 6. 13 microcoulomb divided by, what's the capacitance? 2 into 10 to the power minus 6. So this will cancel. We will get 6.5 volt. So once we know, here it is 6.5 volt, here what will be left? 3.5 volt. So if you apply 10 volt, still this capacitor is rated to 10 volt. 2 microfarad capacitor is rated to 10 volt. So we will try with 15 volt. What happens? 15 volt. Q of 4, 15 volt. Q of T, total charge flowing through the series combination. C equivalent multiplied by voltage, that is 15 volts, that equal to C equivalent, what we got? 1.3 microfarad, 10 to the power minus 6 multiplied by, what is the voltage I am taking? 15. Now what we will get? 1.3 multiplied by 15, 1.3 multiplied by 15, we get 19.5. 19.5 into 10 to the power minus 6 coulombs we will get it. Now I'll see what is V1. V1 equal to QT divided by C1. That is 2 microfarad. Therefore 19.5 into 10 to the power minus 6 divided by, what is the capacitor value? 2 microfarad. 2 into 10 to the power minus 6. This will cancel. 19.5 divided by 2. What do we get? We get 9.75. 9.75 volt. So this 15 volt is the maximum voltage it can be applied to this series combination. So answer is option A. Question number 5. See, I am taking more time to solve these questions so that you can learn it, not to just to see the answer. So all of you practice it. Okay, now here a series RLC circuit is connected to the 240 volt 50 Hz line. If R equal to 10 ohms, L equal to 20 millihenry and C equal to 20 microfarad, then the resulting reactance of the circuit is approximately. Okay, reactance is asking, so we have to find XL and XC. We will find XL. XL equal to 2 pi FL. 2 pi, what is the frequency? 50 into L. L equal to 20 millihenry, that is 20 into 10 to the power minus 3. Now first 2 into 50, 100. 100 into 3.14, 314 multiplied by 20 into 10 to the power minus 3. So it comes to 6.5 6280 ohms. It comes to 6.28 ohms. Now we'll find out what is Xc. Xc equal to 1 by 2 pi Fc. It's a capacitive reactance. So 1 divided by 2 pi into frequency is 50, and what is the capacitance he has given? He has given 20 microfarad minus 6. Now this becomes 314. Okay, 314. That is 1 10 to the power 6 will go up. 314 into 20. 314 multiplied by 20. That 6280 it comes. Now 10 to the power 6 divided by 6280. This comes to 159 point. This comes to 159.2 ohms. 159.2 ohms. This we can calculate reactance of the circuit. Reactance equal to, we can write it as minus j omega L plus j omega L. Or else we can write it as XL minus XC. So what is XL? 6.28 minus what is the value of XC? 159.2. 6.28. It comes to 152.9. So this is the answer. Option A. Option A is the answer. Question number 16. Induced volt. Okay. Question number 16. Guy, all of you are there. Okay. Hysteresis loss in a transformer is caused by. Hysteresis is related to magnetism. Okay. Here its answer is option C. Energy consumed in reversing the magnetism of the iron core. Question number 8. Two inductors, that is L1 equal to 32 millihenry and L2 equal to 8 millihenry. Placed parallel to each other on a common core and are common core. That means there is a coupling and are connected in series aiding. It's telling it's aiding also. The mutual inductance is 2 millihenry. That is M equal to 2 millihenry. Coefficient of coupling is the question. K equal to find. Mutual inductance M is given by coupling factor multiplied by square root of 1 L1 L2. Here M equal to 2 millihenry. 2 into 10 to the power minus 3. K we have to find. What is L1 L2? Millihenry, you can just, both side millihenry is there, so you can take it off. Okay, now let me write 32 millihenry, and what is the other one? It is 8 millihenry. 10 to the power minus 3. 10 to the power minus 3. So 1 minus 3 definitely comes out. Okay, so 2 into 10 to the power minus 3 will get K multiplied by 10 to the power minus 3 into what? 32 into 8 equal to 256. 32 multiplied by 8 equal to 256. It's a perfect square root of square root. That is square root of answer equal to 16. Okay. So minus 3 cancels. 2 equals k multiplied by 16. Left side and right side we can divide by 2. So it will be 1 equals 8k. So k equals 1 divided by 8. 1 divided by 8 comes to 0.125. 0.125. So the answer is option A. This is okay. This question is based on LR circuit. Okay, the question, I'll read the question. The given circuit, the switch is closed at t equal to 0. The time taken for the circuit current to reach steady state value is, okay, to reach for capacitor or to reach steady state. Capacitor or inductor. Inductor. We need phi time constant, that is phi tau. Phi time constant is constant required for the circuit to reach either RC circuit or RL circuit to steady state. Now, what is the time constant of LR circuit? Is that is L divided by R. What is the value of L here? 200 millihenry divided by R equal to 2 ohm, which equal to 200 10 to the power minus 3 divided by 2. 2 cancels. So it is 100 millisecond. 100 millisecond. 1 tau, that is tau equal to 100 milliseconds. But for the circuit to reach steady state, we need 5 time constants. Okay, we need 5 time constant to reach for the circuit to reach steady state. Now we have to find 5 tau. 5 tau will give the time, that is 5 multiplied by 100 millisecond, that is 500 millisecond, which equals 0.5 seconds. So the answer is option D, 0.5 seconds. Guys, question number 9. This is based on the capacitance of a capacitor. That means, okay, I'll tell you. Two metal plates of 2 and 3 centimeters are separated by 0.11 mm with air as dielectric. The value of capacitance will be, capacitance is given by C equal to A epsilon naught epsilon R divided by D. Area is telling, area, what is the area? 2 multiplied by 3. Both are in centimeters, but we need it in meters. So multiply by 10 to the power minus 4. With air as dielectric. So epsilon naught equal to 8.85 into 10 to the power minus 12. For air, dielectric equal to 1. That is epsilon R equal to 1 divided by D. D is given as 0.1 mm. 0.1 mm, but we need it in meters. So 10 to the power minus 3. To convert from centimeter to meter, we will multiply by minus 2. From millimeter to meter, we will multiply by 10 to the power minus 3. Okay, 10 to the power minus 3. I have to solve. Okay, now, okay. Now we'll simplify it. 6 10 to the power minus 3. This will reduce, this can be written as 10 to the power minus 4. Okay, so this cancels. I can write it as 1 into 10 to the power minus 4. So this cancelled. Now what is there on the numerator? Numerator only we have to solve. That is 6. 2 into 3, 6. 6 multiplied by 8.85, which comes to 53.1. That is 53.1 multiplied by 10 to the power minus 12. What is 10 to the power minus 12? That is picofarad. So this capacitor is equal to 53.1 picofarad. That is the answer. 53.1 picofarad. Answer is option B. 53.1 picofarad. So this is the equation you should remember. Then only you can solve it. Question number 10. Three capacitors of 1 microfarad, 2 microfarad and 3 microfarad are connected in series across 10 volts supply. Which of them will have more amount of charge? When capacitors are connected in series combination, I already told you one of the previous questions. What I have told you? I did not say anything. I told you what I told you. Charge will be equal. All capacitors will have the same charge. Same charge will be flowing through a series combination of capacitors. So answer is option D. All will have same charge. Question number 11. How many 2K into 8 ROM chips would be required to build a 16 into 8 memory system? Whenever you get a question like this, just write n equal to required divided by available. What is the required? 16K multiplied by 8. What you have? 2K multiplied by 8 you have. 8 cancels. K cancels. You'll get 8. So the answer equal to 8. Option C. Question number 12. Which is simplified expression for the output corresponding to the given K-map? Okay, the K-map is given. How do you draw a K-map? We have two total how many variables? 4 variables. That is A, B and C, D. I will add one more column down. 1, 2, once more I will divide it. Okay. Now what is given? AB. Here he has given all are 0, 0, K-map. Okay. 0, 0, 0, 0, 1, 1, 1, 1. Who have 1? I don't know who have 1. Now, okay, now what is this here? This is A bar, B bar. This is A, B, A bar, B. This is A, B. What is this? A, B bar. This is based on gray code. Okay. This is C bar, D bar. This is C, D bar, C, D. C, C, D bar. Now here it is actually D and C bar. Okay, this is correct. Okay, now see, now this is a 4 variable. This is like a chord in Carnot map. When we solve a chord will give two variable result. Result should be two variable. If it's a octet, you will get one variable result. Octet, octet, result equal to one variable, one variable. Okay, now we are solving chord. See now what happens? These all a bars you see here. When I solve this, all this will get cancels. How many a bars are there? 1, 2. How many a's are 2? How many b bars are there? 2. How many b's? These all get cancels. And it will be left with CD. It will be left with CD. So the answer is option C, CD. Question number 13. Which of the following phasor diagram represents the series LCR circuit at resonance? Do you know what is resonance? All of you know. There's no doubt about it. So I'm happy with it. So we'll see. Oh, he's asking at resonance what is the diagram, phasor diagram. Okay, now we'll solve it. So we'll solve it together. Now, when XL equal to XC, this let me take it center. When XL equal to XC, resonance happens. Correct? XL equal to XC. And now I'm not writing which is XL, which is XC. And at resonance, this is our resistor current. At resonance current and current to the resistor will be in same phase. This is the resonance current. Our resistor voltage and resonance current will be in same phase. Okay, so that is correct. Now we have how many times we have? Okay, these two we can neglect. These two are gone because resistor voltage and resonance current are not in phase. It has to be in phase. Now if we see here, now we have to choose one of these. If I take this diagram, current is leading. Current I leading here. I leading, I leading, I leading, and VL is here. VL, that's the inductor. Inductor normally current supposed to lag. So this also we can. This also wrong. When I come here, it is correct. Current is leading. Current is leading, and the component is VC. In capacitor, current leads. So capacitor current leads. Okay, that is why see when you compare VC capacitor voltage with current, it is correct because current is leading and capacitor voltage is lagging. So this is VC and this is VL. So the answer is option C. Understand it. I hope you got it. Practice yourself. Try to understand yourself. Then only you can solve it. Question number 14. A transformer has a primary to secondary turns ratio 1:2. That means 1 volt if you give the primary, secondary will get 2 volt. 50 volt RMS 50 Hz sine wave is applied at primary winding. The peak secondary voltage will be. Here he is saying RMS. Okay. Now it is 1:2. So 50 volt RMS I give, I will get 100 volt RMS. Now how to convert RMS to 100 volt RMS volt to peak voltage, that is 1.41 multiplied by 100 will give peak voltage. This by seeing itself we can understand the answer is option C, 141.4. Question number 15. In the circuit shown below, if the input voltage increases, When input voltage increases, what happens? The current flowing through this resistor current will increase. This current will increase. I increases. IT total will keep on increasing. If the current, which current remains practically constant? Which current remains? Because load is fixed. Load is fixed. So when load is fixed, IL can't vary. IL fixed. Load is fixed. Load IL is fixed. Okay, IL is fixed. Then what is the vary? The zener should take whatever the extra current coming in. That is IB. IZ will vary. So the answer is B. Question number 16. To solve this question, you do not know anything about a transistor. Okay. What is the approximate value of saturation current? When at saturation, this transistor will act like a short circuit. Okay. So normally the emitter will be connected to ground, 0 volt. And so this will get short circuit when it is saturation. So 28 volt is coming, 28 volt is here, and this is 1K. What is the saturation current? I saturation, IC sat equal to what? V by R. V equal to what? 28 minus 0 divided by 1K. So it is 28 milliamps of current will flow. So the answer is option A. Question number 17. 10 volt peak to peak carrier is amplitude a 240 kilohertz. 10 volt peak to peak carrier is amplitude modulated using 1 kilohertz sine wave of 3 volt peak to peak. What is the modulation index? The question is very simple. But how to solve it? Let's see. So what is, we have a carrier. uh, it's an amplitude modulation, no? It's an amplitude modulation. So carrier is like this. My drawing skills are very bad. So carrier is like this. Carrier amplitude changes and frequency remains constant in amplitude modulation. Now how your amplitude modulated wave? This is what is okay. Now we'll get a wave like this. When amplitude modulated, we get something like this. Okay. So this is the V max. Now there's one. Oh, now what is modulation index? Modulation MIL, right? It modulation index equal to change in carrier amplitude. Oh, I write here MI. Modulation index equal to change in. And what is the signal? Signal I not show you. Signal is like this. Okay. So he's telling 3 volt peak to peak. That is 1.5 plus 1.5 here and minus 1.5 here. 1.5 here. Negative 1.5 is here. That is what he told, 3 volt peak to peak. Change in carrier frequency, carrier amplitude. I'll write amplitude minus original or normal. That is normal. Original carrier amplitude. This A is amplitude divided by original carrier amplitude. So what it comes? Change in carrier. See, so 10 volt peak to peak carrier is same. So if we will take each side 5 volt, 5 volt. Okay, 5 volt, 5 volt. Now when it goes to 5 volt, what is the value it could increase? 5 volt plus 1.5, 1.5, that is 6.5. So this will be at, this max will be at 6.5 volt. This is the minimum point. Okay, 6.5 volt here. It is 6.5 volt. Original. What is the original carrier? That is 5 volt. I am taking only half of the. For A, we need only half of the wave to transmit information. What is the original carrier? Original carrier is 5 volt peak to peak. So now if you see, we'll get 1.5 divided by 5. That is equal to zero point 0.3. So zero point 0.3 is the modulation index. The answer is option B. Okay, so one more thing. When the carrier goes, what is the minimum value of this amplitude? It's the amplitude modulated wave. Okay, this is the amplitude AM wave, modulated wave, amplitude modulated wave. Now, in case, what is the minimum value it will go in the other direction? That is 5 minus 1.5. You will get, we are taking only, this is our reference, this we are taking the top side. So 5 minus 1.5, it will go to 3.5. So here, if we see, V max equal to V max of AM wave, okay, AM wave equal to 6.5 and V min equal to 3.5. In case, if in the question, if they instead of giving the peak to peak values of both carrier and signal, they can give AM waves maximum value and minimum value. Let's see, this is a AM wave, it will be like this. This is a AM wave, amplitude modulated wave. Okay, now once you know the maximum value and minimum value of it, you can find the, I'll write it to the top. Okay, modulation index M equal to V max minus V min divided by V max plus V min. So which comes to, let us solve for this question. What is the V max? 6.5. 6.5, which M equal to 6.5 plus 1.5. No, 3.5. That is the minimum. Divided by, no, minus subtraction. Okay, minus sum of both. 6.5, that is 10. What it comes? It comes to 3. 6 minus 3, that is 0.3. We'll get same answer. So two methods are there to find the modulation index. Refer once. Okay, we'll go to the next question. Question number 18. In an amplitude modulated signal, modulating frequency is 10 kilohertz and the modulation index is 0.6. What should be the best suited RC time constant for the envelope detector? It is the detector side, that is the receiver side. Modulating signal. See, this we have to take care of this only. You have to find what is the detector required. It is 10 kilohertz. F equal to modulating message signal, that is FM equal to F suffix M equal to 10 kilohertz. What is the time constant? T equal to 1 by 10 into 10 to the power minus 3. Oh no, kilohertz 3. That equal to 0.1 millisecond. 0.1 millisecond. Okay, now to make a envelope detector, envelope detector, time constant should be less than tau of message signal or modulating signal. This is also time constant. So if you compare all these, this is 0.02 is lesser than 0.1 millisecond. So the answer is option B. Question number 19. This is a theoretical question. I'll directly write the answer. I'll try to make some videos on 8051. The function of add ALE signal in 8051 microcontroller is ALE means address latch enable. Address latch enable. Answer is option B, to control demultiplexing the address and data bus. Question number 20. 1. A continuous signal is given by x of t equal to 5 cos 100 pi t. What is the minimum sampling rate required to avoid aliasing? This one signal is given, one continuous signal is given. How I say continuous? Because x of t is a continuous time. 5 cos 100 pi t. What is the normal equation for a continuous time signal? We have to compare it. That is a cos omega t, which equal to, this is the general equation, a cos 2 pi f t. Okay, now we will compare these two. A equal to 5. We want the frequency. We have to find the frequency. Once we find the frequency, what is required? We have to apply the Nyquist criteria. Now let us find the frequency. What is the frequency of this continuous signal? A equal to 5. If we see this signal, A equal to 5. A equal to 5. 2 pi ft equal to what? 100 pi t. Pi and pi t, we can cancel it. So what is left? 2f. 2f equals 100. What is f? F equal to 100 divided by 2, which equal to 50, 50 hertz, which equal to 50 hertz. So 100 divided by 2 equal to 50 hertz. 100 divided by 2 equal to 50 hertz. F1 call K. 50 hertz. Now, okay. Now we got the frequency. What is Nyquist criterion? As per Nyquist criterion, QUIST, I think, criterion, sampling frequency should be double of the sampling frequency, should be 2 times the signal frequency. Okay, so this has to, so what is 50 hertz? 50 hertz we have to sample by 200 samples per second. No, 50 hertz, no, 100 samples per second. Answer is option A. Question number 21. Which of the following can be employed for position sensing? Answer is potentiometer. How potentiometer? If you go to shopping mall, car game is there. Car racing games are there in the shopping mall. If you go there, you are turning the wheel. I write it wheel because turning the steering. It's not wheel, steering wheel, steering. When you turn, this attaches a potentiometer. Okay, this potentiometer, this potentiometer is connected to the steering using some small gears so that it can use to sense the position. Question number 22. Optical fiber communication works on the principle of. The answer is total internal reflection. Total internal reflection. One more internal reflection. Cladding. See, that's core. Take it as this is the core. cladding, which will have more higher refractive index. N refractive index, that is N of core, is greater than N of cladding. In another video, I told you how to remember. Okay, N of cladding. Question number 23. Which of the following is not suitable for broadcast communication? Say olden days where we had TV. Terrestrial communication we used with the repeaters, we used to transmit TV signal. Then we used the microwave communication, and then we used the satellite communication. Okay, these all are suitable for broadcast communication. So the answer is option D, optical fiber communication. This we are not using for broadcast communication. Question number 24. A reverse voltage of 10 volt is applied across a silicon diode. What is the voltage across the depletion region? When a reverse biased, this diode doesn't conduct. If it doesn't conduct, the same voltage will be across the depletion region. So the answer is option C, 10 volt. Okay. Now this is what is this circuit. What is this circuit? Decreasing the gain in the given circuit could be achieved by, first of all, what is the gain equation? This is an inverting amplifier. How do I say inverting amplifier? Input is given at the input is here, negative terminal. So I am saying it as a, and there's a feedback resistor. So gain equal to RF divided by RI multiplied by V in. This is the, now if you want to reduce the gain, what you will do? The denominator you have to reduce. Ri should be reduced. To reduce the Ri should be increased. If Ri increases, gain decreases. So Ri increases, gain decreases. Decreasing the gain of the circuit could be achieved by what? Increasing the value of Ri. So friends, I hope it was useful for you. The next part is the second part, and 2017 16 question paper also one part is pending. So all I'll be uploading soon. So if you study well, please take care. Thank you for watching. Thank you.